In this video, I'm going to look at the start of a database, SQLAlchemy, that has Beatles songs in it. And so I'm going to just start with two tables, and then I will add more to it in the next video. And in this video, I'm going to have two entities, songs and albums. And so then I need to figure out the relationship of these. And I'm going to pick albums. I'm going to ignore any greatest hit albums. And I'm going to say that a song is on one album. That's why I'm ignoring the greatest hits albums, because then a song may be on more than one album, but I wanted a one-to-many relationship. So I'm going to just skip the greatest hits albums and say a song is on one album, but an album has many songs. And so these entities then, under these restrictions, have a one-to-many relationship. And then we will see that when we're making the tables, we want like this sort of atomic behavior in a database. And so we are looking for where is the one, where's the thing atomic. And so the song is going to have the album ID as a foreign key. Okay, so that's what we're going to set up. We bring in the creative engine, the declarative base, the column is, what we're having, the various properties or something. Don't know if I have an integer because I do have an integer. The song primary key is going to be integer. My album ID is going to be a string, which I think in the times I've used it before, I've used all my IDs were integers, but now just the song is an integer, but the album, I already have some data already written for this. And the way it's written, I have primary keys for the album, but integer will be the primary key of a song, string for the title of the song and the name of the album, and so on, and foreign key to establish the relationship to appear in the song and give it a relationship back over to album. I need sessions, and then I'm going to, the foreign key will relate my song to an album, and then I will use this concept of relationship in the album class to sort of serve as a connection back to the songs. And that won't be explicitly in the database, but that will be in our SQLAlchemy sort of, representation of these entities and their relationship. I'm making the database, and I'm just going to do it in memory. I'm going to sort of write, I'm going to add the Beatles themselves in the next round. So this one I didn't want to save because it's the next one I want to save. So I just made an in-memory database. But if I wanted it to save this as it was, then I would put something here, .db. Bring in the declarative base. Here is my album class. I'm extending the SQLAlchemy base class. The name of the table is going to be album. It's the same. Well, this is small a, that's capital A, but the name of the class is capital A, album, and the name of the table over that's eventually made in SQLite is album. Okay. Could be different. They don't need to be the same, but could be record or something if you go back far enough. So that's maybe a confusing term in database because record means something database. Okay. I have an ID. My album ID is going to be a string because my data file, here's my data file for albums, Beatles albums.txt. I already had in this data file keys, and those keys were strings. So I'm going to have a key string. And the reason, one is that my data files already existed, and so I'm going to obey with them. And then over here, I have the song, and I have that foreign key over here in the song. So I already had that sort of set up in my data files. So I'm sticking to that. And so that's why here my primary key for the album is a string that I've already made. And in previous examples I had the data in a JSON file instead of having two separate files. And this this setup is more akin to how the database is arranged, with uh, this serving as a primary key of album and this serving as a foreign key of song. That's more the way that database actually is, as opposed to the last time I did one of these one-to-many, sort of two-table one-to-many databases. I got the data from JSON, and that sort of made the relationship in a different way. Okay. So I have that album class. It has the ID, which is a string. It is a primary key, so they better be unique. The album has a title, which is a string. There's an image. I'm not doing anything with those images, but I had them in the file. I had them in my data file, so I'm keeping that. And then I have album has a relationship to song. And here I am in song. It also extends the base. It's going to correspond to a table named song. It's has an ID. The songs have IDs. These are going to be, I don't have them. I don't have any IDs here in the song file. So for this one, I am going to auto increment. So I have my primary key is an integer in this case. There's going to be a song title, and then there's going to be a foreign key connecting us back to the album. And again, when we express our relationship, um, a song is on one album, an album has many songs, then that says that one, that those the appearance of the word one and many tells us it's one to many relationship. And the one is, when we write it this way, the one is going to be the thing that gets the foreign key. So the song entity, the song table, will get the foreign key. And here it is in the song class. We are making a foreign key, connecting it to the album. And here is the table. So I'm not connecting it. So foreign key is a table idea, is a database idea. And so this is small a album, and album, small a album was the name of the table. Whereas up here, the relationship, that's not a thing really in the database. That is more a thing of the class. And so this relationship is to the class, whereas the foreign key is a table thing. You'll actually see these in the table as they are in these text files as well. Set up our session, set up to read a data file. Read the first data file. We're going to do albums and then songs. So reading the text file for albums, which was in static data. There were no headers in this file, so I don't have any code to like skip the first line. I read all the lines. I'm getting rid of any blank lines. I'm getting rid of any sort of extra white space on the ends. It's comma delimited, so I'm splitting on a comma. I'm in album. It has three things separated by these commas. And the first one was the ID, the album ID, which was a string. The second, the title, and the third one, that image. I am adding the image. That's equivalent to an insert. It will handle the insert code for me. And then I am committing. So if I wait to commit to the end, then I might flush so that I get the IDs, but I decided to just commit at this stage. Then I'm reading the Beatles songs, and again, it's got a TXT extension, but it's basically a CSV file, comma separated values file. I'm looping. There were no headers. In some previous thing that I stole this from, I was doing some kind of counting, but I'm not doing counting here. So this I equals 0 has no business being here. Deal with the blank lines, deal with any extra white space, split it on a comma. This has 2. The song has 2 properties in the text file, the title and the foreign key. And so I'm setting up the title, I'm setting the foreign key. It had an ID, um, and it was an integer, and I'm auto incrementing. So I don't need to put it here in the constructor or add it because it's just going to take care of itself and auto increment. I'm adding it. And then again, when I'm done, I am committing. I could individually query the album and the song and loop through all of the uh, so this I could loop through the album titles and then the record title, the song titles and the album titles. I guess I called it the album. Yeah, I called it no, I called it album title, not title, and song title. So this should have been album record dot album title, and this should have been record dot song title. But it's commented out anyway. Um, so now here's my real uncommented query, the query that, and I'm going to just query album, but I'm going to rely on the relationship that we established in the album class. And so I'm looping, I query the album table and get albums. I have all here, so it's setting up a list, and then I'm looping over the list. I'm calling the element of the list an album, and that's basically a dictionary. And then I am printing out with some funky console underlining the album and its title. And then I have this nested loop inside where I'm doing an album dot songs. That is, songs was the name of the relationship. Scrolling up. Songs was the name of the relationship of album to the song class. And so these are the songs that belong to a particular album. So this is an album. This is one of the albums. I'm looping over the songs. I'm looping over a song as my sort of dummy index name. So the an album has songs in the relationship. So that'll be a list of songs. And then I'm using the here I do have it right, album title and song title. Okay. And so let's just run it. Then we see the results of the query. And so we have the Beatles songs, Please Please Me as an album. Here are the songs on that album. Here's with the Beatles, here are the songs on the Beatles, my little weird underlining here. And that's what this query does. So it gives you the natural join of album to song. That's what the relationship does. So I don't have to explicitly write a query with a join and have a where clause that matches the foreign key to the foreign key of song to the primary key of album. That just is done for me by SQLAlchemy because of this relationship I said that I have. Okay, that's it for this one. Thanks for your attention.